Hi, welcome back. In this video, we'll be doing a quick introduction to modular arithmetic. Modular arithmetic comes into play when we only care about the remainder of a value when it is divided by a positive integer. For example, we might ask a question like, what time is it now in Sydney, Australia? This is a question of that form because time is based on a remainder when you divide by 24 hours in a day. Another example is if we asked, what is the last digit of 7 to the 2001 power? This question is not asking for the value of 7 to the 2001 power. Instead, the last digit of an integer is the remainder when you divide that number by 10. Here's another example. What day of the week is it 2 months from today? Days of the week are based on a cycle that repeats every 7 days. So it's like we're dividing by 7. One more example. What is the remainder of 3 plus 3 to the third plus 3 to the fifth plus ... plus 3 to the 29th is divided by 8. So this question is explicitly asking us for a remainder when we're dividing by 8. So this concept of modular arithmetic involves solving for a remainder when you divide some expression by an integer m. That's where the modular comes from in modular arithmetic. And the numbers that we'll be dividing by m are expressions that involve adding, subtracting, multiplying, and exponentiating. And that's where the arithmetic comes from in modular arithmetic. There's a couple of things we need to know before we get started. The first is that we'll be seeing the word mod used in a couple of different ways. What we're used to is when we have an integer a, we can write a mod 3, and in this expression, the word mod is an operator. It's calculating the remainder when you divide by 3, and so this expression always equals either 0, 1, or 2. And in general, when the mod is an integer m, a mod m is one of 0, 1, 2, up to m minus 1. In the next few videos, we'll be seeing the word mod used in a different way. We'll be writing this, a triple bar b parenthesis mod m, end parenthesis. This means that a and b have the same remainder when divided by m. This triple bar notation, it's like an equal sign, but with an extra horizontal line, is read is congruent to, or is equivalent to. So we would say a is equivalent to b mod m, or a is congruent to b mod m. The second thing to notice is that this triple bar always pairs with the mod m at the end. That tells us the modulus under which a and b are congruent. So how are those two notations related? What we said is that a is congruent to b mod m is the same as a mod m is equal to b mod m. Notice that in the first expression this is an equivalent sign, whereas in the second equation this is actually an equal sign. These two numbers are equal. A third equivalent expression is that m divides a minus b. So let's determine if a is equivalent to negative 2 mod 3. Let's do it in the first way. What is 10 mod 3? 10 is equal to 3 times 3 plus 1. So 10 mod 3 is equal to 1. Negative 2 is equal to 3 times negative 1 plus 1. So negative 2 mod 3 is equal to 1. So yes, 10 is equivalent to negative 2 mod 3. Now let's do it the second way. Calculate 10 minus negative 2, that's 12. And does 3 divide 12? Yes, 12 is equal to 3 times 4. And so our conclusion is the same. 10 is equivalent to negative 2 mod 3. One more useful thing to know is that there's some additional language and notation surrounding modular arithmetic. Instead of saying, find the remainder of the expression when you divide by m, often you'll see something that says, find or compute that expression modulo m. These two sentences mean the same thing. Because modular arithmetic is always looking for remainders, we have a special notation for the set of possible remainders, z sub m, and that's the set 0, 1, 2, up to m minus 1. When you have a question involving modular arithmetic, your final answer will always be in this set, z sub m. Your calculations may take you outside of the set z sub m, but you should always find your answer between 0 and m minus 1 inclusive. That's it for now. See you shortly.